Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to complete the surface integral, but we will be doing or evaluating surface integrals in the presence of a vector field. Last time we did the scalar field. Today, we are going to do the vector field. So again, if we have any surface like in 3D, uh, we at any point we can always construct two vectors that are tangential to that surface, right? At any point. So let's say one of them along the u direction and the other along the v direction. So basically, if that's parametrized, then this tangent would be the partial derivative of r with respect to u, and this would be the partial derivative of r with respect to v. So like the scalar field exactly so far. Notice that because f is a vector field, basically I will have a surface integral of the vector field. I don't want the vector field in space in any direction. I want its projection normal to the surface. How do I get a vector perpendicular to the surface? Think cross product, right? RU, R sub U cross R sub V will give me a vector. What do I know about this vector? I know, first of all, that its magnitude that we calculated last time is the area of the parallelogram in which RU and RV are two sides. But I know that that's the magnitude, but the direction is perpendicular to the surface. Really, if you remember how what's the meaning of a cross product, it's the magnitude of the first vector times the magnitude of the second vector times sine of the angle theta between RU and RV times a unit vector, we call it n. That's n for normal. If you do r, the magnitude of this times the magnitude of that times the sine of the angle between them, it will give you the area of this parallelogram. If after that you multiply it by n, which is a unit vector, it will give you the area of what we call a parallelepiped. So the volume, not the area, I'm sorry, the volume of the parallelepiped that has RU and RV are the two sides at the base, and the height is 1 because the magnitude of the normal vector, hey, that's a unit vector. But I'm going to take this force or this field and project it onto the normal. I want it to be perpendicular. So really what I'm calculating is the volume of the parallelepiped in which the base is made of RU and RV as the parallelogram, and the height now becomes the projection of the force perpendicular to that parallelogram. How do we project any vector onto any other vector? We say dot n. It gives you the magnitude of the field times the magnitude of n, and then I'm gonna do that ds. So that will give me the total integral over the surface. Okay, so step number one, if we are not having a parametrized surface, gonna do the parametrization. Step number two, we are going to take that parametrization and find RU and RV. Step number three, we are going to get the cross product of RU and and RV. Step number four, we're going to perform a dot product between F and NDS, which is RU cross RV. So that basically will give me double integral over this domain of F dot. Instead of writing NDS, it's basically RU cross RV du dv. And that's basically what we are going to do. That's the fifth step, is to take the integral. Okay? So notice that this dot product would result in a scalar quantity. Yes, we are in a vector field, but the cross product is vector, F is vector, but when I perform a dot product, I get the magnitude of the force projected perpendicular to the surface. Okay? It looks too much, but it's really pretty straightforward. I prepared a couple of examples here again. So here is number one. It tells you evaluate that surface integral. And my field is yi plus xj plus zk. And that surface is bounded at the bottom by the xy plane and at the top by the paraboloid z equals 1 minus x squared minus y squared. So minus meaning it's opening down, something that looks like a parabola opening down, but it's volume, right? So basically you can say here is the back and here is the front, and it's centered at the origin. We know that the radius is 1, right? This radius is 1. I'm sorry, the radius at the base. The radius at the base is 1 of that circle, right? How do you know that? Because at this, they tell you it's bounded by the xy plane, meaning when z becomes 0. And if z is 0, you get x squared plus y squared equals 1. That's the equation of a circle of radius 1, right? And if we say this is the x, this is the y, this is the z, what we need to do, again, we can parameterize by using, instead of substituting x is y, x is u and y is v, just use x and y, right? There's no reason, like what we did last time was just, we were just doing it, but we really didn't need it. So what we are going to do now is to write the parameterization R of x and y is basically xi plus yj, and z is a function of x and y, so I'm going to write it plus 1 minus x squared minus y squared in the k direction. They told you there is an equation. If it's like that, you get the cross product as the negative partial derivative with respect to x and the negative partial derivative with respect to y, and 1 in the k direction. There is no reason to memorize that. Just perform the cross product. So we can get r sub x, meaning the partial derivative with respect to x, which gives me I plus 0j, because it doesn't have x, minus 2xk. And when I do r cross y, meaning the partial derivative with respect to y, I get 0i plus j minus 2yk. So now rx cross ry, this operation doesn't take much time, right? I, j, k, 1, 0, negative 2x, 0, 1, negative 2y. Oops, I'm sorry, I forgot the x. Equals. So in the I direction, I get 0 minus negative 2x, so 2xi. In the j, I do it backwards, so 0 minus negative 2y, minus negative, so plus 2yj. And then in the k, you get 1, so plus k. My f is already yi plus xj plus zk. So when I perform f dot Rx cross Ry, I should get 2xy. Notice I dot I is 1, j dot j is 1, k dot k is 1, and I dot j or I dot k or j dot I or k dot j or anything is 0, right? By definition, because the magnitude of each one of the i's, j's, and k's is 1. So you say 1 time 1 time the cosine of the angle between them, and all of them are orthogonal. The angle between them is pi over 2, and cosine pi over 2 is 0. That's why when you do I dot j or k dot j or any such uh, dot product, you get 0. So you are only interested in the i's, the j's, and the k's, and the answer is scalar. There is no I, j, k in the answer, as unfortunately sometimes I see. So I get 2xy, there is no I, plus 2yx, meaning plus 2xy again, plus z. But guess what? I cannot write z. I don't have a z here. So I have to write it plus 1 minus x squared minus y squared equals 4xy minus x squared minus y squared plus 1. An advice, every time you see x squared plus y squared, think polar coordinates. Okay? So we are going to say, if I want to integrate that, instead of integrating that with respect to x and y, and notice x and y here are related by an equation of a circle, no, don't do that. I'm going to say x is r cos theta, y is r sine theta, and when I square them both and add them up, I get r squared here and r squared there. So I took them out, factoring them. And between parentheses, I will get cos square theta plus sine square theta, which is 1. And that's the equation of a circle whose radius is r, right? And r goes from 0 to 1. Wait, so this, you learn that sine square plus cosine square of any angle is an identity in trig. I made a video that is posted in mathematics. It's about my ninth grader, Malenki, the student I mentioned there. I would want you to watch that. I think you would love it. Anyway, so we are going to do here the double integration of this quantity, 4xy. So 4xy would be r squared cos theta sine theta minus r squared plus 1. R goes from 0 to 1. As we saw, it's 0 here and it's 1. It goes from 0 to 1. And theta goes from 0 to 2 pi. Now, dx dy is what? Remember, it's not dr d theta, it's r dr d theta. So I multiply that by r dr d theta, which becomes the double integral from 0 to 1 and 0 to 2 pi of 4r cubed. When you multiply r, just distribute the r, cos theta sine theta minus r cubed plus r dr d theta. So we are going to integrate with respect to r first. I have my outer integral 0 to 2 pi. And then when I take the antiderivative of 4r cubed, I get 4 times r to the 4 over 4. The 4's cancel, and you get r to the 4 cos theta sine theta minus r to the 4 over 4 plus r squared over 2 evaluated from 0 to 1 d theta. Notice when you evaluate at 1, Uh, this is 1, this is 1, this is 1. So you get the integral from 0 to 2 pi of cos theta sine theta minus a quarter plus 1/2, so plus a quarter, just to save time. So here I have two integrals. You have to learn that you really don't need substitution. I shouldn't say hate, because my granddaughter, if she hears me, she would put me in trouble. Yes, she's 3.5 years old, but she put me in trouble when I say a yucky word like hate. So I don't like, okay? Don't tell her I said that. So instead of doing substitution, do you know that the derivative of sine is cosine? So I will rewrite this as the integral from 0 to 2 pi of cosine theta d cosine theta. And you say, what? What's that? I know dx. No, you can take the derivative with respect to anything. Anything. What is the derivative of cosine? I'm sorry, I made them backwards. This should be sine, and uh that should be sine. No, no, that should be sine, and that should be sine d sine. Why did I say that? Yeah, the derivative of sine is cosine, right? So I should have done it backwards. I should have said it's sine theta d sine theta. What does that mean? It means, what is the derivative of sine? It's cosine. So d sine theta would be cosine theta d theta, which gets you back what you had. So, but if I write it like that, you know how to integrate x dx, right? You say x squared over 2. So integrating sine theta d sine theta will give me sine squared theta over 2, evaluated from 0 to 2 pi, plus integral here is theta over 4, evaluated from 0 to 2 pi. Notice that sine 2 pi and sine 0 are zeros, so this becomes 0, and you get 2 pi over 4, which is pi over 2, and that's the answer. What I mean is that I could have said, let u equals cos theta. You don't need that. Then du becomes, uh, I I did it the other way around. Let u equal sine theta, then du becomes cosine of theta d theta. So now cosine theta d theta becomes du, and sine theta is u. So now you will get the integral of u du. The problem with that, it's not a problem. You can integrate with u by changing the limits of integration, or you can find u squared over 2 and then substitute back, so you get sine squared theta over 2, which is here. So it saves time if you can see that one of the two multiplied function is the derivative of the other. I know that cosine is the derivative of sine, so instead of writing cosine, I write a d sine. Again, it took me longer than what I wanted, but I got myself confused, but it's really pretty straightforward. Think which one is the derivative of the other. I could have used negative cosine theta d cosine theta. It's the same thing, right? So I would integrate from 0 to 2 pi, but negative, so it would cancel each other anyway. Um, because when you square, the negative 1 would become 1, so you would be subtracting 1 from 1 anyway. Okay, uh, the second example. In this second example, I want to evaluate this function, but they give me a parametrization. So they took the x and the y and found that x is u, but y is v square minus u. And the z, which doesn't exist in the field, was u plus v. So it's a little tricky. I'm not going to say x is u and y is v. No. X is u, yes, but y is u minus v squared because this is negative y. Or negative y would be u minus v squared. Anyway, let's see how we are going to do that. And they give you u goes from 0 to 3 and v from 0 to 4. So the first thing we do is to take the derivative of r with respect to u. So I get I minus j plus k. And rv, there is no v here, so 0I plus 2vj plus k. Then you perform the cross product. You get, I didn't write RU cross RV just to save time because I don't want this to be very long. 1, negative 1, 1, 0, 2v1. So in the I get negative 1 minus 2v, negative 1 minus 2vi. In the j, I get 0 minus 1, so minus j. And then in the k, I get 2v minus 0, so plus 2vk. Now I'm going to rewrite the force using the parameters because I no longer use x and y. So I have negative y, which would be u minus v square in the I direction, u minus v square in the I, plus xj, the x is u, so plus uj plus 0k. And I perform the dot product of f dot ru cross rv. So here you see what I'm going to do. I'm going to multiply all four, so like FOIL, right? I get negative u minus 2uv plus v squared plus 2v cubed, all of that by multiplying the i's. Then the g's, I get minus u, and then the k's, I get 0. So that becomes 2v cubed plus v squared minus 2uv minus 2u. And I'm going to perform the integral right away. Maybe I'll start with the u. The u goes from 0 to 3, and the v goes from 0 to 4. Let's write that so you know which is which. But you would see du comes before that, before the dv. So 2v cubed plus v squared minus 2uv minus 2u du dv equals integral from 0 to 4 of 2uv cubed. Notice we are integrating with respect to u, so the v becomes a constant, plus uv squared minus 2u squared. Antiderivative is u squared over 2. The 2 and the 2 cancel, so minus u squared v minus u squared, because over 2 times 2 dv. And this is evaluated from 0 to 3, which becomes, notice the 0, I don't care about it because I subtract 0. So in the 3, I get 6v cubed plus 3v squared minus 9v minus 9 dv. So when you integrate, the antiderivative of v cubed is v to the 4 over 4. 6 over 4 is 3 halves. So you get 3v to the 4 over 2, right? V cubed over 3, the 3's cancel, so plus v cubed minus 9 halves v minus 9v. And the v is evaluated from 0 to 4. So I have to do the 4. 4 to the fourth is 16 times 16, which is 256, but you divide by 2, so you get 128, and 128 times 3 is 384. Right? Yeah. V cube, 4 cube is 64, minus. If V is 4 over 2 is 2 times 9 is 18. 4 times 9 is 36. These two add to 54. I think when I worked it out, I got a different value. I remember that. I'm sorry, let me check quickly. I didn't do any mistakes for you. I minus j plus k, no I, 2v. Oh yeah, I see it. I see it. I'm so sorry. Should I redo the video? No. Okay. You see here it says negative yi. Negative y. No, I thought I forgot to switch those. I said that must be the reason. No, it's not. This is negative y, u minus v squared, so it's correct. And this is x. So you get negative u plus v squared minus 2uv plus 2v cubed minus y plus 0. So 2v cubed plus v squared minus that minus u, and negative u is negative 2u. Did I write everything correctly? Now when I integrate, I get 2u uv squared minus u squared v minus u squared. I evaluated at 3, so you get 6v cubed plus 3v squared minus 9v minus 9. V over 4, say 4 over 4. So 6 over 4 is 3 halves. V cube over 3, so that's V cube minus 9 half V square. Oh my God, that's bad. Minus 9V. So 4 squared is 16 over 2 is 8. So that's minus 72. Okay, 64 minus 72 is negative 8, minus 36 is negative 44, so 384 minus 44 is 340. It's getting too late. I have to go to bed. I shouldn't be doing videos. Sorry, guys. Yeah. Of course, the last step. So you have to check everything. Everything is fine, except, and I wouldn't know that except that I did this example before. I remember the final answer, but there is a square here. I really apologize. I hope that wasn't bad. But again, if you have any questions, let me know. Um, I will try to respond to you as soon as I can. Thank you very much for your time. Sorry for the trouble, and until we meet again, I wish you all the best.